Welcome to the world of three-dimensional geometry. Today we are introducing a new axis that opens up a whole new geometric world. In 2D geometry, we are limited to a flat surface, moving left, right, forward, or backward. But how do we locate a flying drone or an airplane in the sky? For that, we need the third dimension. We need a new axis to define depth and height. This new axis is called the Z-axis. Applications of 3D geometry include GPS navigation, modern architecture, and game development. Now, let's see how these three axes come into existence. The axes are formed by the lines of intersection of three mutually perpendicular planes. These planes divide space into 8 regions called octants. Now, let's take a tour of these 8 octants. Let's start with octant 1. It's the space where X, Y, and Z are all positive. Think of it as the top right front corner of a box. Plus, plus, plus. Now, let's move counterclockwise on the top floor. We enter octant 2. Here we've moved backward along the x-axis, so x becomes negative, but y and z stay positive. Minus, plus, plus. Continuing around, we hit octant 3. Now both x and y are negative, but we are still on the top floor, so z remains positive. And finishing the top level, we have octant 4. X is positive again, but y is negative. Plus, minus, plus. Now for the basement. Directly below octant 1 is octant 5. It's exactly the same, except now we are below the floor, so z becomes negative. Plus, plus, plus. The pattern continues downstairs. Octant 6 is below octant 2. Octant 7 is the opposite of octant 1. Everything is negative here. And finally, octant 8, completing our tour. Plus, minus, minus. Remember, the x and y signs tell you which corner you're in. And don't memorize the table, just visualize it. Here is a pro tip to choose octant of a point by their coordinates. Look at z to pick the floor, up or down. Then look at x and y to pick the corner. Let's the test immediately at. Consider the point P -4, 2, -5. Step 1. Look at z. It's -5, which is negative. So we take the elevator downstairs to the bottom level. We instantly know our answer must be octant 5, 6, 7, or 8. Step 2. Look at x and y. We have -4, 2. That's negative x, positive y. In basic 2D geometry, that lands you in the second quadrant. Step 3. Combine them. We need the second quadrant of the basement. That lands us squarely in octant 6. So no table memorization required. Now, we know the octants. So let's find a specific spot, a point. To find point P, we just follow a path starting from the center. First walk along the x-axis. Then turn and walk along the y-axis. Finally go up. Walk along the z-axis. Here's your point. These numbers just tell us how far to move. Let's look at an example. P2, 3, 4. Start at the center. Take 2 steps on x, 3 steps on y, and 4 steps up. Easy. What about negative numbers? Let's try Q, -3, -2. X is negative, so walk back 3 steps. Y is negative, so go left 2 steps. Z is positive, so go up 2 steps. Just remember, X is forward and back, Y is left and right, Z is up and down. Before we start measuring the distance between 2 points, let's do a quick check to see if you've mastered octants. Consider the point P2, -3, 4. Can you visualize which octant it belongs to? Pause the video and take a moment to visualize it. Let's break it down. Z is positive, 4, so we are definitely upstairs, octants 1 to 4. X is positive, Y is negative. In 2D, plus minus is the 4th quadrant. So combining upstairs with 4th quadrant, we land in octant 4. Did you get it right? If you have any doubt, then comment box is open for you.